And welcome to Nani Notes. Well, here we have another class activity, and yes, I want you to write them all out. Last time, we arranged the letters of a word, all unique letters. This time, we're just going to pick, in this case, 2 out of the 5, and see how many ways we can arrange them. All right, let's get to it. Now, I suppose in my mind, what I would do is I'll block out 3 at a time so I can focus on 2 letters. Okay, well, I got 2 letters here. I've got a W, okay, and I've got an H. That's one arrangement of those 2 letters. But I could also say I've got this arrangement, H, W, or from the South, W. Now, I'm saying, all right, I think that's all the ways that I can pick those 2. Well, I could have picked the W and the A. Well, let's try that. I've got the W and the A, which can also be arranged A, W. I know you're writing these out because I want to see it. Okay, how about if I go, well, W and L? Well, I've got W, L, or L, W. Boy, a lot of possibilities here, aren't there? And remember, the order matters in this exercise. How about the W and the E? Let's try that. The W and the E, and the W. Woof. Wow. Well, now let's look at it this way. Let's look at, that's all the possibilities that contain the W. Let's move on to the H. Now, the H and the W are already taken care of, so that's not really going to matter. I mean, that's, so we're going to say, start with this. H and, well, let's be consistent. Do it the same way. How about H and A? We don't have that yet. We've got H. We've got A. We've got A. And we've got H. Okay? H and L. Check it out. We don't have it yet. H and L, L, and H. Very good. We don't have an H and an E yet. H, E, E, H. Whew. You know, that looks like it takes care. That's going to take care of all of our H's, doesn't it? So I guess we're going to move on to the A. Oh, I guess I should have made some more. Well, no, I guess not. We can just look at it like this. Now, A and W are already taken care of. A and H are already taken care of. Now we look at the A. Well, we don't have A and L yet. You see how this pattern is going. And of course, the reverse of that, we have L and A. Now, I don't see an A and an E there. A, E, and let's take E, A. Nice. Okay. Well, I think we've got all the combinations with the A's. Now we've got those 3 blocked out. We've only got 2 letters left. So let's arrange them. L and E, they haven't been paired yet. And E and L. All right, That should do it. Let's count them up. 2, 3, 4, 5, 6, 7, 8. 8 times 2 is 16, 17, 18, 19, 20. So that's our experiment. We came up with 20, actually 20 ways to arrange 2 letters taken at random from the word whale, where all 5 are unique letters. Okay. There must be a name for this. There must be a name for this. I wish there was a name. Oops. Well, that's kind of giving you the answer right away. Of course there is. It's permutations. And in the case of permutations, the order matters. We'll get to examples where the order doesn't matter, but right now we're on order matters. So let's do this. How many ways can you arrange, okay, 1, that means you, how many ways can you arrange 2 elements chosen from 5 unique? That sounds like the previous page. Well, I'm going to write it this way, a 5 P2, and these 2 are both in subscripts, meaning they're down low, like that. 5 in the front, 2 in the back. And we could read that 5 permute 2. I guess if you're into Shakespeare, nobody really says that. But permutations 5, 2 out of 5, or 5 comma 2. But this is the old school way of writing it, and that's the way it looks on your calculator. So 5 permute 2. I've got a formula right there. Heavens to Murgatroyds, that's awesome. Now, N, that's the 5. The 2 is the R. N says, how many elements are there total? And the R says, well, how many are you going to select and arrange? Now, this formula is really slick. So let's try it out. We're going to substitute in here. I've got 5, well, on the last page, whale. You had 5 letters, and you were going to choose 2 of them and arrange them all the different ways. I'm going to substitute in here 5 factorial. We learned about factorials in the previous lesson, and we've got 5 minus 2 factorial. And I can say, well, 5 minus 2, that's going to be 3. Now, let's do the expansion like we did before. Remember what it means. 5 times 4 times 3 times 2 times 1. And that's going to give us, well, that's 5 factorial. This is 3 factorial. Now I could multiply those out, but you know I can also do this. I can divide. 2 divided by 2, divide out the like terms. And what am I left with? I'm left with 4 times 5. How many did we get? Hey, wait a minute. How many did we get over there? 20? Well, check this out. It looks like we have 20. 5 times 4. There's exactly 20 ways to arrange 2 elements out of 5 unique elements. And there they are. Whew. Let's keep going. Now, let's change it up a little bit. Let's look at how much different it would have been if instead of choosing 2 letters out of whale, let's say we chose 3. How many ways could we arrange them? Well, let's find out. Again, we could say 5 permute 3. And I would write it this way. 5 factorial over 3 minus 5. That quantity factorial. Whew, simplify that. We all know inside the, please, excuse my dear Aunt Sally, we know we must solve what is in the parentheses first. 5 minus 3 is 2. So now I've got 5 factorial over 2 factorial. Remember, this is the difference between choosing 3 letters instead of 2. Let's see how much it does. See what we got there. Now, we expand it, and it looks kind of familiar. Of course, 1, of course the 1's divide out. And I'm left with 5 times 4 times 3. Well, that's 20 times 3, which is, of course, 60. Or you could say 3 times as many as, well, as the previous example where we just took 2 letters. That's why we didn't write this one out. I didn't want to put you guys through that. That would have been 60. Wow. We just wrote out 20. I think that was good enough to get the idea. All right. I think we got to take this, step this up a notch, and let's suppose we go a little bit bigger. They don't have to be letters either. They're just elements. Could be giraffe, zebra, leopard, or it could be, in this case, little colored dots. And I'm looking there, and I've got 10 unique elements, 10 unique colored dots. And I want to figure out how many ways I could arrange 6 of them. Oh no, we're not going to do this. It'll take too long. So we're just going to calculate this one. And again, this is 10 permute 6. So let's go with our formula. Well, we've got our formula up there because we've got this down by now. And we're just going to do the substitution. 10 factorial. 10 minus 6 factorial. Well, we simplify. We've got 10 factorial over 4 factorial. Expand that out. Heavens to Murgatroyds, look at that. And we're going to roll this up a little bit so we're going off the page. And we can see you've got 10 times 9 times 8 times 7, etc., etc. And of course, we got all the common factors that divide out. The 2s, the 3s, oh, I'm getting kind of messy there, the 4s. And what we're left with is a really big number. If I had to get my calculator out, and there it is, and I mean, you might need your calculator for this. 10 times 9 times 8 times 7 times 6, wow, times 5. That's a big number, 151,200. Yikes. That's a lot of arrangements. That is a lot of arrangements. Okay, tired of this yet? Nah, I don't think so. I want to revisit an assignment we did earlier. You remember before we took the letters of math, because every class does that, M-A-T-H? Well, we use that to represent a factorial. Well, that's how we first learned about factorials. Remember, we got 24 and we wrote them all out. Boy, that took forever. But you say, wait a minute, that may be a factorial, but it's actually a permutation where n is equal to r. Now, pay careful attention to this. There's something really slick comes up here. So again, we already did this. We already know the answer is 24. You actually wrote them all out. You arranged math using all 4 letters and all the unique ways you could write it out. And there they are. And it's right there in your notes. So we're going to do this. Well, let's suppose I say 4 permute 4. Well, that's 4 factorial over 4 minus 4 factorial. And here comes the trick, because when you simplify that, you get ruh-roh. You get that 0. And you've been trained forever. You've been trained since the beginning of your mathematical career that division by 0 is undefined. You can't divide by 0. Divide by 0 and go to jail. You can't do it. And it's undefined slope, all those things. But 0 factorial is not 0. This is a little freaky thing. 0 factorial is the same as 1 factorial. It's 1. Now, you can think of it a lot of different ways, like maybe how many ways can you choose nothing? Well, there's one way to choose nothing. Nothing. So it's a little different. It's not the number 0. 0 factorial is 1. Now, that makes all the difference in the world. Because when I expand this, I've got this. 4 times 3 times 2 times 1. Now, just like we did in the last lesson, the previous lesson, when we first learned about factorials, really, this simplifies to being, you divide it by 1, 4 permute 4 is the same as 4 factorial. 4 times 3 times 2 times 1. And there you go. 4 times 3 is 12, times 2 is 24. Boom shakalaka, just like we got last time. 24. Okay. You know, we could really use a word problem here. You could really use a word problem here. And let's go with this one. All right. The WNBA has 12 teams. You all should know that. Now, how many ways can the teams finish the season? Well, with the ranking, the first, second, third. Now, this doesn't say that there's a probability. It just says how many ways can you pick it. There's stronger teams than others. I mean, maybe you're thinking UCONN Huskies. Hey, time for some name dropping. Yeah, a friend of mine coached Rebecca Lobo. So that's what made me think of this. So way back in the WNBA days, let's get to this. Well, we got to understand, what are we being asked? Does the order matter? First, second, third. I would think if you had a bronze medal, you would, or you had a gold medal in the Olympics, you're not going to swap it for a bronze because they're all the same. No, no, no. Order matters. Does the order matter? You betcha. The order does. So you are going to choose this as a permutation function. NPR. N permute R. So I am going to identify N must be the number of teams, the 12 teams. R is the ranking. And then we're going to substitute 12 teams, 12 factorial over 12 minus 3 factorial. I'm going to simplify that. 12 factorial over 9 factorial. Now this time, you know, I'm getting tired of writing 12 times 11 times 10 all the way down to 1. So watch this. I'm going to write it a more clever way. And we hinted at this in the last video. Remember, 12 times 11 times 10 times 9 times 8 times 7. You can just leave this part as 9 factorial, because that means from 9 down. And I'm going to leave this as 9 factorial. I don't need to write out 9, 8, 7, 6, 5, 4, 3, 2, 1. I'm just going to write it like that. Way slicker. Look at that. I'll just divide it out like that. Beauteous Maximus. 12 times 11 times 10. We could almost do this in your heads, but I'm kind of lazy myself. So I'm going to say 12. Clear out the old one. 12 times 11 times 10 equals, wow, 1,320 possible ways to have first, second, third place teams. That's amazing. Again, it's not saying the probabilities. That could depend on team strengths and that. This just tells you how many possible, how many permutations, how many ways could I have these winners, not their likelihood. So there you go. I hope you've learned something today. And you're going, most likely, I'm going to ask you to turn this in. I think I just did. And that's that. Hey, and on the subject of calculators, you all see me typing in these numbers. It is possible. I want to leave you with this thought. Some of you have this button on your calculator. The bummer is I don't have it on my, on the built-in calculator here. And if you do have that button, experiment with it. Go back to one of the problems where you already know the answer. Like 5p2, 5 permute 2, 5 permute 3. We already worked them out. And see if you can use this button on your calculator to get the answer. Always experiment with your machine to see how it works. Some of them may have different order. I know if honestly, I think any calculator over $9 is going to have this button on it. And you'll be able to type in, perhaps you'll type in the number 5, then the NPR button, then 3, and then the enter. I don't know. Every calculator is different. Work it out. Practice until you get the answer you already know is correct. Now, alternatively, you can also search on the internet. I didn't want to demonstrate this because I don't want to endorse anyone. Plus, there are so many different permutation calculators. And they'll all look like this, and then you'll just type in a number for N, a number for R, and hit enter, and you'll get an answer. But again, put in numbers. Always, always, always experiment. Put in numbers where you already know the answer, the ones that we did. Put those numbers in and see if you can confirm the correct answer before you trust what the calculator says.